Okay, we are now recording. Now we'll go to the current slide. This is where we left off last time. But a couple of things. I had promised you Friday that I was going to take all the materials over to the Birmingham campus, try to get as much of Blackboard caught up as possible. Before I could even start that, I had to cancel 3 classes of math department chair. I always like to call students before I cancel the class. I got the first student called in the first class, and then everything broke loose. People coming in, people not there. I was having to help people find stuff. It kept up that way all day Friday. I mean, literally, I did not get back. I finally had to cancel the 3 classes right before I left without contacting another student because they had to be canceled before the end of the business on Friday. I was there way later than what I had intended to be or supposed to be. And I got 0 done on Blackboard. So over the weekend, I carried it on home with me to do it there, but we were out of town part of the weekend. And Sunday evening, when I was getting things ready to do, Blackboard was down. Okay, I could not get Blackboard to come up, so I got things done, but I couldn't put it loaded on Blackboard. And then yesterday, in my 2 hours, we had all sorts of things happening, including finding the new text. And I pointed out that one before. This is now the current text. You can use either one. If you have the older text, when I opened to this page, I thought I had the wrong book because this is identical, absolutely identical to the same 2 pages in the old edition. So there's so little change, it's pathetic. I think I told you before that the only reason I can tell that they changed editions so they can sell new books. Because the publisher only makes money on new books, they don't make money on used books. So they make new editions come out every 3 or 4 years just so they can sell new books. Nothing, now I'm sure there's some changes somewhere in the book. It's thicker, not much thicker, but a little bit. So there's got to be some changes somewhere, but so far I haven't seen any of them. So this company is a rip, but the author is great. So sorry about that. Now, there's something in the new book that was not in the old book, and that's the new book always had CalcShack.com. Now there's a new program. This is what makes this author so good. He has CalcView.com that you can go to, and I haven't figured out what the difference is, but you can go to that as well. He has another one, we'll get to that later. It's Precalculus, or LarsonPrecalculus.com. He has 3 separate websites, all of which give supplementary material to the text. It's absolutely free. Has nothing to do that I can tell with WebAssign or anything else. They show you how to work problems. It's just, he is the best author of running. I mean, the math is the same, but you know, as far as providing supplementary materials for free, this guy's got it. That's why I like him. And we're changing to him in calculus as well, so if any of you hang around for calculus, you'll get the same author there too. Okay. But between yesterday afternoon and last evening at home, I was able to get finally all of your stuff loaded on Blackboard. Okay? I've got the syllabus there. I hope I've made all the corrections to it. The research paper, I think I've got all the corrections to that. My locator card, all those websites that I've collected over the years that students say found helpful or I thought might be helpful. The link to the YouTube videos, you can just go to the link, click on that, and go straight to the playlist and pick out the videos. Now, I think I mentioned this to you before, but let me say it again. The YouTube does things, I guess it's reasonably. The oldest stuff is at the top, the newest stuff is at the bottom. Okay? So, if you're looking for stuff we've done, go to the bottom of the playlist, and that's that. What I don't do, though, I don't delete the other stuff in case you want to look ahead. It'll be what we did last time I taught the course, which is last spring. If you want to look at some of that ahead of time, you can. So it's all out there for you, for your viewing pleasure. but when I do put a new thing in, if it duplicates something that was out there, I delete the old. So it's a huge playlist, I mean a pretty good sized playlist, 25 to 30 sessions on it, but the ones we've done are just those at the bottom of that. Okay, then also I got all the PowerPoint done last night at home because I'll leave my computer here on Monday, Wednesday for Dr. Bryant to use for his physics classes. So I had to use a laptop we have at home that we don't use very much. It has that sorry Windows Vista operating system, the worst I think I've ever seen. It did not interact well with Blackboard, so it was very, very slow getting the things loaded, but I finally got them loaded, and by that time it ran out of battery power, so I had to go plug it in. I said, I'm tired, I'm going to quit. So 113 didn't get theirs done, but you got yours done. So I think everything's out there for you now. Okay. Any questions on anything we've covered so far? Okay, last time we were talking about functions, and this is introduction to functions and function notation. We've mentioned, and this is a compilation of what we've mentioned so far, 4 ways to represent a function. Verbally, you can make a sentence or description of what that is. You know, the function of your age and your height, I mean, or something like that. I mean, there's no really important correlation there, but you only have one age and you only have one height, okay? So that could be a function, okay? Verbally, or written out in a sentence. Numerically, you can do this in form of a table, the good old T-table that you did when you were graphing. X, Y, now it's X, F of X, okay? Or you can do it horizontally, X, F of X, however you want to do that. Or list of ordered pairs. That does the same thing as a table. It just puts them in ordered pair. You put it as a set, so the brace in front, ordered pair, comma, ordered pair, comma, ordered pair, and you can do it that way. Now, obviously to do numerically, either of those methods I said, a table or a set of ordered pairs, you have to have what we call a finite set. An infinite set is sort of hard to do that way, and you, whereas verbally, you can just describe it and leave it going to infinity. Numerically, if you're going to list them all, they have to be finite. We also call that a discrete set. In other words, you might have so many heights, okay, but or ages, or whichever you want to do first, but usually those are years. Not many of you are probably 66, but something like that. And we usually do that. It's not continuous. It's 66, 35, 20, 18, whatever. Those would be a discrete finite set. Graphically, okay, I can't remember if we've done one of these yet, but we will be doing graphically. We'll plot the points on a graph on the coordinate system. Usually the horizontal axis represents the input values, which are called the, what set? Domain. And the vertical axis represents the output value? Range. Very good. We always call them X and Y. They don't have to be X and Y. Whatever input. Another name for it is the input values are the independent variables. Okay? The vertical axis, the output values, dependent variables or values. Or you can list it algebraically by an equation, an expression, a formula, something like that. After a little bit in this first part, we're going to be doing almost everything that way, then doing it graphically, occasionally numerically, and the problems will give it verbally. So we'll use them all, but we're going to focus on that a lot more later. Okay. So let's look at example. Oh, wait. To determine whether a relation is a function, how can you tell that? What's the difference between any old relation and a function? Yes?
All right. The same two x values cannot have a different y.
Yeah, exactly. Okay? For a function. A relation could, okay, but a function cannot. To determine whether a relation is a function, you must decide whether each input value, okay, is matched by exactly one output value. The same input can have two outputs. That would be a relation, it wouldn't be a function. When any input value is matched by two or more output values, it is a relation, but it's not a function. Okay, so here's example 1. Determine whether the relationship or relation represented y as a function of x. Okay? The input value x is the number of representatives from a state. The output value y is the number of senators from that state. Is that a function or not? The input is x, okay, number of representatives. The output is y, number of senators. Is y a function of x? Why not?
Same two inputs can give different outputs.
Okay, what two inputs will give you different outputs?
Two can't be 11 and also 10.
Again, okay. But remember, your input is your number of representatives. The output is the y, the number of senators. How many representatives does Alabama have? Does anyone know? Huh?
We can't have that, can we?
What's that?
We can't have that, can we? We got.
Okay. The question was, did you answer that? How many is Alabama? 10? 2. No, senators, 2. Representatives. 7, is it? Yeah. Something like that. 9? Okay, maybe. I didn't know it was that high. But anyway, there's some number. How many senators do we have? 2. Okay? For whatever. Wyoming has 1 representative. How many senators? 2. Okay. California, I don't know how many it has. 50 or 60? How many senators? 2. Okay. So any number of representatives, whatever it is, there's only one number of senators. 2. So that is a function. A bit bizarre function. It has a name, by the way. That would be a constant function. Because your y is always 2. Always 2. A constant function. Any x you choose here, the answer is one and only one answer, 2. Okay? It doesn't have to be a constant function to be a function, but that is a function. How about this one, number B? Oh, that's the one you were doing. I wondered where you got that. Okay. Okay. He's jumping ahead. He's ahead of it. Okay, never mind. Okay, what about B? Not a function. Because you have input twice, different outputs, can't be a function. It is a relation. C, there's a graphical one. Say again? Is a function? Absolutely. Pick an input, -2, one and only one output. -1, one and only one output. 0, one and only one output. 1, one and only one output. 2, same thing. Okay? That is a function. Now, what would have been a dead giveaway on that graph if it had something like this? Say again? Then you would have, let's say, this was 1 and 0 rather than that. So for 2, if you had 1 and you also had 0, guess what you have? Yeah. You have a vertical line that contains 2 points. Any vertical line you draw here can contain only 1 point. I'm jumping way ahead. It's going to be a test we're going to do for graphical representations of functions. That is a really simple test. It's called the vertical line test. We'll get there later. Okay? Any questions? So let's see what the verbal description does describe y as a function of x. Regardless of the value for x, the y is always 2. Okay? Such functions are called constant functions. Graph is horizontal lines. Okay? The second one, the table does not describe y as a function of x because the input value 2 matched by 2 different y values can't be a function. And the third one, the graph does describe a function of x. Each input value is matched by exactly one output value. Very good. Now, representing functions by sets of ordered pairs is common in, this is what I was talking about before, discrete mathematics. Finite number of elements, and they have unique values, okay? In algebra, however, it's much more common to represent functions by equations, formulas, okay, expressions involving two variables. For instance, y is equal to x squared, okay? Y is some function of x. Is that a function or not? What do you think?
Yeah.
Okay, give me an x. Second? 2. What's your y? 4. Only one y. But if you gave me negative 2, guess what? You still got 4, but guess what? Still only one y for that x. So you can have more than one. You can get y more than once for different x's. That's fine. You just can't have it the other way. By the way, when I was calling roll, I think someone came in, and I probably didn't get you. I just remembered when she came in. Anyone whose name I did not call, let me know. Didn't someone come in? What was your name? Oh, I did get you. Okay, you were in the later part of the alphabet. Okay, and Ebony, got it. There you are. Anyone else whose name I did not call? I didn't count. I should count. I don't even have that up anymore. So y'all don't get counted today. Okay. You don't count. Okay. This represents y as a function of variable x. In this equation, x is the independent variable. This is what I was saying before. I didn't know I was jumping ahead. Y is dependent variable. Because you get to choose any value for x at all. Give me an x. You can give me any x. But once you give me an x, y is fixed. Y depends on x. So that's why the y is called the dependent variable. Okay. What was the domain? Remind me, what is the domain of a function? Second? The set of all possible input values. Okay? Taken on by the independent variable x, and the range is then the values that your set of all values that then your y dependent variable could have. So you determine the x, the domain, and then the range depends on what values y can take. Now let's go back to this one. What do you think would be the input here? What values could x take on? Yes. Anything. All real numbers from negative infinity to positive infinity. What values could y take on? Say again? Just positive values, because there's no value that you can put in for x here and get a negative y. You can't get 0, which is neither positive or negative, but non-negative values. So you see, that one has unlimited x, but somewhat of a restriction on y. Very good. Any questions? Okay. When using an equation to represent a function, it's convenient to name the function for easy reference. Now, what can we name a function? Function. What's our favorite name? What's our favorite name for a variable? X. Everybody wants to call it x. Okay, but you can have y and q and p and r and t and all sorts of things. Guess what everybody's favorite function name is? F. F. Yes, exactly. Function f, I guess. Okay. Now, for example, you know that this equation, y is equal to 1 minus x squared. Okay? Does that describe y as a function of x? Sure it does. Any x you choose gives you only one y, right? Okay. Suppose you want to write that and get the name of that function. F? Oh, what a clever name. Then you use the function notation. Now, this sounds really elementary and almost silly, but if you remember this, you've got most of this course not. The simple thing to remember, y is equal to f of x. Now, it's not always, okay, but if you remember that, you basically got it not, okay? So if your input is f, is x, your output up here was y, now we're going to call it f of x. So this equation becomes f of x equal 1 minus x squared, okay? Now, if you remember that, the independent variable becomes your function. I mean, the dependent variable becomes your function of the independent variable. So what goes on the inside is the independent variable. What the F represents is the dependent variable. Remember that. If you just remember y is equal to f of x, 90% of the time you got everything knocked right there. Okay? Now, the symbol f of x is read like that. You could say the value of f evaluated at x or f of x. Okay? Guess which one I'm going to say? F of x. Okay? Really easy to say. The symbol f of x corresponds to the y value. That's what I was just saying. If you remember that, your dependent variable is your function. Okay? So y is equal to f of x. So remember I said, if you know how to do equations, you know how to do functions. Just making the y f of x. So you can write y is equal to f of x when y is your dependent variable. Now, it's not always, admit it. Not always is y your f of x, but most of the time it is. Keep in mind that f is the name of the function, like Fred or Sue or something like that, whereas f of x is the value of the function. Okay, sort of a silly distinction, but it is there. For instance, in this function, okay, give me an x. 4. Okay, what's your f of x? F of 4. Second? -5. Very good. Give me another x. Second? 2. What's your f of 2? Okay, you're reading my arm, aren't you? Okay, never mind.
No, I said 6.
Oh, 6. Okay, I can't hear you. Okay, what is 6? Okay, what is f of 6? Second? -9. Excellent. Okay, so you see. How about let's do this? F of -1. What would that be? 5. What about f of 0? My favorite. 3. Okay, just move that 0. Okay, that's easy. F of 2. Did we already do? No, I want to do it, but you didn't. Okay, I got it. What's f of 2? -1. Very good. To find those values, you substitute. In other words, what you do with Glade, plug it in, plug it in. So that's all you do here. If you're given an x, plug it in here, plug it in there. That gives you the value. Right? Okay. Functions aren't that bad. Okay, here they do what we just said. They got f of -1 was 5, like y'all said. F of 0 is 3, and f of 2 was -1. Although f is often used as a convenient function name, all functions are not f, okay? And x is often used as an independent variable. It doesn't have to be. You can use other letters for either one, okay? Most of the time we don't use the function name of x because we usually use that. You don't go around and say x of x. No, that doesn't make any sense, okay? F of x is this, x squared minus 4x plus 7. F of t squared minus 4t plus 7. Guess what? It's the same function, okay? It has the same name. Really, the independent variable, it sounds like I'm making fun of it. It's a dummy variable. Doesn't matter what it is, you're going to plug in the same thing on both sides. Or you could name it g of x, g of s, okay? S squared minus 4s plus 7. The function is the thing that takes whatever you put into it, squares it, subtracts 4 times it, and adds 7 to it. That's what the functions do it, okay? When I don't think I had ever heard the concept of function when I was in high school. And I went to Georgia Tech, and at Georgia Tech, unless you're an industrial management major, that's the only major back when I went, that first quarter there, you took Calculus 1. And I came from a small rural high school in Georgia that we didn't have anything but Algebra 1 your freshman year, and they changed it, but at one time it was Algebra 2 your sophomore, and they swapped it in Geometry your junior, but they swapped them. And then Advanced Algebra and Trig. That was it, okay? No pre-calculus, no course like this. And when I went to Georgia Tech, calculus. That's the first time I had heard the word function. I had a great professor, though. Hard, but he was really good. Kept me lost the whole time, but at the end, when I look back on it, I said, oh, this makes sense. But I was always lost in the sauce on the way. But he did this. He said, what a function is, he said, think of a black box, okay? And he actually drew it, okay? He drew better than I do. A black box, let me get my thing to look at least like it might be black, okay? A black box here, okay? And here you have an input. Here you have a crank that you're going to turn the crank. I shouldn't have that there. And here you have an output. Okay? You feed in input, your domain, your independent variable, turn the crank, that's the function, and then you get the output here. There's your y, your f of x. Okay? Now, as soon as he said that, it made sense to me. Because I went back thinking I grew up on a farm in Georgia, and every winter, my dad tried to find the coldest day of winter, and that's when we had our hog killing, okay? And because we raised, chicken, pigs, cows, and things, garden and everything. We didn't make a lot of money, but I ate really well, okay? But when we had a hog killing, especially when I was really young, there wasn't much I could do. I was just too young and too small to do it, but my dad and anyone he had to help, my mom and his brother would come over, whoever, and they would help and do all the things. The job I could do was grind sausage. And we had a old sausage grinder, and when he put the handle on it, I went right to the sausage grinder. And it actually looked like it. It had a spout here, and it was long like this, and out the end came the sausage. Here he put it. While Dad was cutting up the meat, if there was ever a scrap that had lean in it, he'd throw it into a pile. Now I wondered, why is that pile there? Anything that was trimming, if it had lean meat in it, he threw it into that pile. The pork chops, the ham roast, whatever it was, anything, a little bit of meat, he would put over there, okay? And then when that all got done, packaged that, moved it away, brought out the sausage grinder, okay? And that was my job then, to turn the crank on the sausage grinder. And they would put in those pieces of scrap lean meat and put in the spices, put in the peppers, put in the sage, put in whatever they were going to put into it, and then would come out the sausage. The input, the output. The sausage grinder was a function. To this day, I remember this, and that's what I do. So, you see, the function here is the same. What this function is doing, rather than grinding sausage, is taking the input, squaring it, minus 4 times it, and adding 7 to it. That's what that function is doing. The previous one just took the input, squared it, and threw it out. Okay? That was the output. That's what a function does. No matter what you call it, no matter what the input you put into it, you could do a stick man. G of stick man would be stick man squared minus 4 stick man plus 7. I mean, whatever you want to call it, that's your function. Okay? So, really, the independent variable is so important because he's independent, No, it's just a dummy placeholder. Okay, that's all it is. All right, so it could be a block. Okay, alpha block is block squared minus 4 blocks plus 7. It could be anything. Now, a function divided by 2 or more equations over a specified domain. This should be on a separate slide. Why they have this on the previous slide, on that slide, they just wanted to take up room, I guess. Okay. Before we get there, okay, in fact, there is a huge gap here. I may have gotten, I jumped the gun. Let's go back and do example 2. But before I do example 2, if you got your books, you see this picture of this beautiful looking mathematician, Leonard Euler. Handsome guy, okay, right? He was considered to be one of the greatest mathematicians ever to live, okay? Probably falls right in there with Isaac Newton and Archimedes. I mean, he was incredible. Many consider him, he was a Swiss mathematician, to be the most prolific and productive mathematician in history. Okay? One of his greatest influences in math was to use the symbol. He came up with this alphabet notation. Blame it on him. If you don't like it, Euler's fault. Okay? There's so many things he did do. And if my memory's right, or several with similar names, I believe he's the one that when he was like 5, 6, or 7, something like that, his dad was sort of a bookkeeper, and he was playing around with his, while his dad was working. He said, "Dad, you made a mistake here." Some long list of numbers he had been adding. He said, "You made a mistake here." In fact, and his dad was really a bright guy, and found out, sure enough, he saw it. I think he may have been the one that, y'all never would like this, but back then the kids were really cutting up really badly in school one day. So the teacher said, "All right, all of you get out your slates or whatever and add the first 100 numbers together and give me an answer." He thought, that'll keep these little people busy for a while. And Euler was in the class. I think it was Euler. And in just a few minutes, he said, "I've got it." I said, "You can't possibly have it." And he said, "Show it to me." And this is a young kid. And what he had done, have y'all heard this one? Yeah. So let's do 1, 2, 3, 4, 5. I'm just going to do it through 10. He did it through 100. 6, 7, 8, 9, 10. If you had to add those together, it wouldn't take too long. But what he did, 1 and 10 is 11. 2 and 9 is 11. 3 and 8 is 11. 4 and 7 is 11. 5 and 6 is 11. 11 times 1, 2, 3, 4, 5. 55. He did that as a young kid, 1 to 100. And he did them 101, 101, 101, 1. Had the answer in no time. Of course, he knew how to multiply. The other kids didn't. But it was just drove that. He could crazy, I think. Okay. Now, if I'm not mistaken also, Euler at some point went blind in one eye and then had some sort of illness or something, and he was losing sight of the other eye. He continued publishing. He remembered everything in his head. He just had a scribe writing it down for him then. Incredible mind. Okay. He could be a paper topic. This isn't your source. You have to get source from outside, but he could be a potential paper topic. Or how did he come up with the f of x notation? That could be not on him, but on that. Or pick anything else. Y'all ever heard of the number E? Yeah, the base of the natural number system. That's why it's named E. After Euler. He's the one who came up with that. He came up with one. Oh, by the way, let me just give you this. We have some real good friends from Germany. And just about every birthday, and sometimes at Christmas too, they are really big on giving gifts. And what they give me just about every time, I love it, are books. Okay? And one book, they gave me one birthday, I think it was. The title of it was The Math Book. Boy, that sounds exciting, doesn't it? Yes. Well, actually, it was a fantastic and a beautiful book. It was 250 of the greatest discoveries in mathematics. And on one page, it would describe that discovery. On the second page was some painting or illustration or something that had to do with that. Beautiful color, thing. It was just really incredible. I didn't get through the month of January before I'd read it. Oh, yeah, it was just fantastic to learn all that stuff and to see the pretty pictures. Once I finished with it, it'd be a great coffee table book, except who's going to read it? So I decided I'd donate it to the library. For a while, they kept it on reserve, but I think they put it on the shelves. Can't remember the name of the author, but if you have a topic you're interested in, or you're looking for a topic, go find that book. The Math Book is the name of it. I mean, that's literally the title. And the last name of the author is a rather complicated name, and that's why I can't remember it. But you can use that as your source, or one of your sources. So it's a beautiful book, so whether you use it or not, well worth a look. Okay. Sorry about all that. Now, let's do example 2. I should have done this back before we did a couple of other things, but let's do example 2. Now, in your new text, they didn't used to say it then, so this is one thing that probably is a little bit of a change. Right here under example 2, it says, see larsonprecalculus.com for interactive version of this type of example. Okay? Also, every time they do an example, like example 1 and 2, they have what they call a checkpoint. And if you'll notice right next to the checkpoint, it says audio, video solutions in English and Spanish are at larsonprecalculus.com. So here you have a web source that you can go to anytime. If you try, I would suggest by all means try to do these checkpoints. Now, if you don't have time to do them in class while I'm up here yakking my mouth, as soon as you get out of class, go back and do the checkpoints. Okay? Because while it's fresh in your mind, you do them. I'm doing them up here, but I'm asking you questions. Hopefully you're participating in it. But you go home or go to the next room or the free period and try to do the checkpoints. Okay? And if you can't get them, then pull up larsonprecalculus.com and you get help in how to do it. Okay? Best way to do this. Okay? So here is number 2. Determine whether each equation represents y as a function of x. Here's A. Okay? X squared plus y is equal to 1. Can any of you look at that and tell me whether y is a function of x or not? How?
Yeah, all you gotta do is just switch around to make it y.
Okay. Here's a good thing. Solve for y. You've done that before, haven't you? Solve for y. How would you do that? Subtract x squared from both sides. Right? Solve for y. Okay, what do we mean by solving for y? Isolate the y. Or put it this way, I want a naked y there. Nothing else. You know, no numbers, no variables, no powers, just the y. So get rid of anything that's not a y, and that would be subtracting x from both sides. And what do you have? This adds a 0. Y is equal to 1 minus x squared. Guess what? This y is a function of x. Give me an x, you get only one y. Right? Pretty simple. Okay? How about this one? Minus x plus y squared is equal to 1. Now, it's not the same problem, but it's pretty similar. Can you just look at that and tell me? Say again? You do what? Add y? Yeah, right. You're trying to isolate the y. So let's add x to both sides. Okay, and what does that give you? So that adds a 0. Y squared is equal to 1 plus x. I didn't ask what y squared was. Oh, yeah. Okay, I saw you writing in the air. What was that you were writing? Square root. Take the square root of both sides. Y is equal to the square root of 1 plus x. Time out, folks. When you take the square root of both sides of an equation, you always have to remember, what's the square root of 4? 2. How about negative 2? Oh, yeah. Okay. Yeah, negative 2 squared is also 4. So guess what? Anytime you take the square root of both sides of an equation, you can have this being y, but this has to be a plus or minus. Plus or minus y. Plus or minus square root of 1 plus x. Is that a function? Give me an x. Say again? 4? 3? Yes, I like 3. Okay. If you give me an x of 3, then this becomes 4. Square root of 4 is 2 plus 2 or minus 2. Guess what? You gave me 1x. You got 2y. Plus 2 minus 2. Not a function. Right? Not a function. Okay? So, that's solve for y. If you get it a unique value, you got it. If not, you don't. Okay. Now we get around to example 3. Oh. They skip example 3, don't they? I think they do. They skip 2, and I think they also skip 3. So let's do 3. All right. Example 3 is let g of x equal to minus x squared plus 4x plus 1. Okay? Find each of the function values. What is g of 2? You tell me what to do. Plug it in, plug it in. Minus, say again, 2 squared plus 4 times 2 plus 1. Okay, they would lead you off with one like this. What in the world does that mean? Okay, very good. Remember your rules of order of operation. Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her, okay? All right. Parentheses first. This doesn't have any, okay? What's next? Exponents. Always do exponents before you get Aunt Sally is adding and subtracting. The kind of negation is that. Do this first before you do that. So this is not negative 2 squared. To have that, you'd have to have that in parentheses. This is minus 2 squared. Okay? So that would be a little louder. Negative 4 plus 8 plus 1 equal 5. Very good. All right. Now, let's do the next one. What is g of t? Negative t squared. Everybody see that? Plus 4t plus 1. Done. All right, how about this one? What is g of x plus 2? Huh? Can you do that? Sure you can. How do you do it? Okay, you start with negative x plus 2 in parentheses squared plus 4 times x plus 2 in parentheses plus 1. All right? And what would that be? Minus. Anyone know the easy way to square a binomial? There's 2 ways, huh?
So since you got 8, do a squared, so that's going to be a squared, then x 2x times 2.
Okay, all right. I think you're saying it right. So you have a minus. Keep that parentheses there. Square the first term, x squared, plus 4x, twice the product of the 2. Okay? Plus 4, square the last term. Now, if you don't remember that, what can you do? Go over to the side and do x plus 2 times x plus 2. And then FOIL it. You know about FOILing, right? First is x times x is x squared. Then you do outer is plus 2x. Then you do inner is plus 2x. And then you do last, right? FOIL. That would be plus 4. Now what you have? A smiley face. But beyond that, what you have is x squared plus 4x plus 2. That's why plus 4. What's wrong with you people? Okay, no. That's why you square the first, twice the product, square the last. That's the easy way to do it. But if you forget it, you can always go back and FOIL it. Okay. And that's all in parentheses after the minus sign. Next, plus 4x plus 8 plus 1. Now we negate the parentheses here, and what does that give us? Negative x squared minus 4x minus 4 plus 4x plus 8. Well, let's make it plus 9 Save writing. I'm lazy. Oh, here's my theory about mathematics in general. I find, or this is just my theory, okay? My theory is to be really good in mathematics, you have to be a little lazy. Do any of you qualify? All right, budding mathematicians here. Don't worry, you folks that work hard, you can still do it, okay? But if you're a little lazy, you're always trying to find the best way, the easiest way to do a problem, okay? So that's my theory. I don't know. I've never seen that proven anywhere. So just add 8 and 1, not to have to write it big. Be lazy, okay? And what does this give us? Negative x squared. The minus 4x plus 4x adds to 0. Plus 5. Got it? You can do that. You plug in an x plus 2, you get out a minus x squared plus 5. You get old sausage grinder, right? Okay. They have a checkpoint there as soon as you get out of class. Whenever you can. Don't be doing it while you're supposed to be doing your English or something. But do as soon as you can, do your checkpoints. All right, now we get to this part, okay? All that was supposed to have been done before, in between this line and that line. Why they put it on one slide, I don't know. Okay, so now we go down here, piecewise defined function. Function defined by 2 or more equations over a specified domain is called a piecewise defined function. Here's an example. All right, here's your function. It's alpha of x is equal to this, x squared plus 1, anytime x is less than 0, and it's x minus 1 anytime x is greater than or equal to 0, right? So, how do we evaluate that function? I've got to find it here. Oh, here it is, okay. We want to know what f of minus 1 is, okay? Now, here's my suggestion for how they do this. When you were young, did you ever play Where's Waldo? All right, you want to figure out where Waldo is. Where is negative 1? Is it here or here? Really? Okay, go back to Waldo. No, okay. Negative 1 is less than 0. Okay? So then, to use negative 1, you use this one. Right? And what would that give you? Plug it in, plug it in. What would it give you? 2. Second? 2. Okay, it's negative 1. This time you put that in parentheses because that x is being squared, plus 1, and that would be 1 plus 1. Didn't know you'd be doing such high-level math today, did you? When you woke up this morning, you didn't know I'd be demanding you to know what 1 plus 1 is, okay? But we got it, all right? How about 0? Alpha of 0. What's the first question you ask yourself? Where's Waldo? Where's 0? Upper or lower? Lower, because that has the minus sign, okay? I mean the equal sign, okay? So that's an equal, that's greater than or equal to. That's what that sign stands for. So we use that one. And what would that be? 0 minus 1 equals negative 1. Perfect. Next, alpha of 1. What'd you ask yourself? Okay, you got sick on this, haven't you? Okay. Where do you go? The bottom one. And what does that? 1 minus 1 equals 0. Very good. Make sense? Okay? That's how you do piecewise defined functions. Graphing them, that's yet another issue. We aren't going to do it yet, but believe me, we'll get there. Okay? Now I'm going to erase this stuff first. Everybody got it? All right? So let's see how they did it. Because negative 1 is less than 0, it fits in the top one, so we use alpha of x equals that to obtain alpha of minus 1 is minus 1 squared, plus 1 is 1 plus 1 is 2. All right, very good. For x equals 0, because this is greater than or equal to 0, we use the bottom one, so it's 0 minus 1, which of course is minus 1. And for x equals 1, that's greater than or equal to 0, so therefore 1 is greater than 0. Find out where you are, use that function, 1 minus 1, and that happens to turn out being 0. Good deal. Make sense? Any questions? All right. Now, I do not understand why they do this, but some of the most important examples that you don't have anywhere else, they just skip them. Okay, so they're skipping example 5 and 6. So let's go back and do, okay, example 5. Finding the values for which f of x is equal to 0. That's what you're looking for. Find all the real values of x for which f of x is equal to 0. When the a part, f of x, is equal to negative 2x plus 10. Okay, so we're sort of doing the backwards thing. Here they tell us what the f of x is, and what is f of x? The dependent variable, exactly, the y, and you got to figure out what the x is that gave you that as the y, or the independent variable that gave you that as dependent. So how are we going to do that?
Plug 0 into y.
Say again?
Plug 0 into y.
Yeah, but we don't. Oh, okay, yeah. And what is your y? F of x. You're absolutely right there. Is that what you meant? All right, I knew you did, okay. You put 0 in for y, which is f of x, and that's equal to minus 2x plus 10. And now you solve for x, right? Right, good deal. And how do you do that? Okay, you could do that. You could subtract 10 from both sides, and that gives you negative 10 is equal to negative 2x. This adds to 0. Then what? Divide by negative 2, and that gives you x is equal to 5. And then you can go back and check it by saying x equals 5 here. Negative 2 times 5 is minus 10 plus 10 is 0. Yeah, that made up of x equals 0. So that's how we do it. Does that make sense? Because f of x is equal to 0. This is f of x. Set that equal to 0. I do it like to do it on that side, but since she made me put it over here, I'll put it there. Yeah. But yeah, she's very demanding. Okay. Let's do the b part. Here your f of x is equal to x squared minus 5x plus 6. Okay? And we want to find all the values of x that would make f of x equal 0. So what do? Set it equal to 0. That's what you were saying, right? All right, good deal. Now, how do we do that? When it's linear, that's pretty easy. Solve for x. When it's quadratic or higher, what do? Okay. I'm hoping no one will get offended if I say this, but in this classroom, what is the F word? Factor. Okay? So, okay, don't add any meaning to that, okay? And that doesn't tell you what we think about factoring. No, that's what the, okay. If anyone's offended, I won't say that. Anyone bothered by that? Okay. All right. So, anytime you've got an equation with a power linear equation, solve for x. But if you have anything with a higher order, you're going to have to factor it or something like that. Can we factor that?
Yes.
Oh, we can. Good. Okay. And how do we factor it? Okay. Now here's, I'll give you my way. You probably can do it very easily. I like to unfoil it. If we multiply them by foiling, why don't we unfoil? So what's the only possible factorization of x squared is x times x, right? Only possible way you can get x squared there would be x times x. Then, now I don't spell very well here, I go to the sign of the last term. And what is that? Plus. That means these two signs have to be, well, they have to be the same. And because the middle sign's minus, they both have to be minus. And then you look for two numbers that multiply to be 6 and add to be 5. 2 and 3. Very good. You were saying that and you did it already in your head, but that's fine. Now what do we do with that? Okay, the only way you can have a product of two entities being 0 And one of those has to be 0. Can you think of any two numbers that multiply together give you 0? Unless one of them is 0. Can't do it. So that means that one of the other of these has to be 0. So either x minus 2 is equal to 0 or x minus 3 is equal to 0. Only way that can happen. Okay? What does the first one give you? Now you got a linear equation. What do we do? Add 2 to both sides, and that gives you x equal 2 or x equal 3. Yeah, you don't even have to do all the math. Okay. I'm a cynic. Okay, I never trust myself because I like to get the right answer. Okay, I want to check and see. Is 2 squared, what's that? 4 minus 5 times 2? Say again? Minus 10, right? 4 minus 10 is negative 6 plus 6 is 0. Yes, I like that. How about this one? Say again? 9 minus 15 is? Negative 6 plus 6 is 0. Yes, okay. They both work. So we found all the values. Now, the question is that all the values? If this is a square, then you can have no more than 2 x's. You may not have 2. You may only have 1. You may have no x's. But you can't have more than 2. Here, what was our exponent? 1. If you don't see an exponent or a coefficient, understand it to be 1. Okay? So that's 1. How many answers we get? 1. Okay? 2, you can get no more than 2. 7, no more than 7. You may not get 7. And this one, you may not get 2. We did get 2. Stop there. Those are all that you can get. Good deal. They do have a checkpoint, by the way. All right. Let's see if we can get the next one in. Any questions on that before we move on? All right. This time, number 6 is finding the values for x for which f of x equals g of x. It says find all the values of x such that f of x is equal to g of x when f of x, this is the a part, is equal to x squared plus 1 and g of x is equal to 3x minus x squared. Okay, how are we going to find those x's?
X squared plus 1 equals 3x.
Yes! Do f of x, which is this, is equal to g of x, which is this, so just write it down that way. X squared plus 1, that's your f of x, is equal to g of x is 3x minus x squared. Now, how are we going to solve that? A little louder? Okay, add x squared to both sides. Get, again, when you have a power greater than 1, get everything on one side and 0 on the other side. So that way, if you can factor, you can get a product, the zero product principle. Okay? So we're going to add x squared to both sides. And let's go on in. Subtract 3x from both sides. And what does that give you on the left? 2x squared minus 3x plus 1 is equal to 0. Very good. And what do we try? Factor if we can. Okay. All right. What's the only possible factorization of 2x squared? 2x times x. Very good. Where do we look next? Sign of the last term is, and what it tells you these two have to be, in this case, negative. They have to be the same, and because the middle is negative, they have to be negative. Now, what's the only possible factorization of 1? 1 and 1. Okay, let's see if that works. With no guarantee, 2x, we foil it now. We unfold it, now let's foil it. 2x times x is 2x squared, that works. 2x times minus 1 is negative 2x minus x, that'd be minus 3x, and plus 1. Yes, that worked. Okay, so what do we do now? So each of them equal to 0. 2x minus 1 equals 0. And what would that be? Or x minus 1 equals 0. That first one, what would we do? Say again? Add 1 to both sides. 2x equal 1 divided by 2. And what does that give us? We love our fractions, don't we? X equal 1/2. The other one? X equal 1. Now, cynic that I am, I want to check to make sure those work. Ooh, I love fractions, okay? If you plug in 1/2 here, what is 1/2 squared? 1/4, exactly. Plus 1. How many fourths is 1? Yeah, 4/4. 1/4 plus 4/4 is 5/4. Okay, so this side is 5/4. What if we put in a 1/2 here? 3/2 minus 1/4. Well, how many fourths is 3/2? 6/4 minus 1/4 is 5/4. Yes, they're the same. That was the easy one. Let's do the hard one. Okay, 1. 1 plus 1 is, oh, we got it again. Y'all remember that from before? Okay. That's 2, and this one would be 3 minus 1 is 2. Yes, they both work. Okay, y'all are acting like you're anxious to leave. I can't believe that. Okay. Oh my goodness gracious. Oh, we didn't get to do the B one. I looked at the answer for B and thought that was the answer to A. I said, they got it wrong. No, they got it right. But we're going to start with the B next time. All right, but we did get far enough along, folks, that we can do some homework exercises. Boy, this is one long section. That was a yay. I was here? Yeah, okay, good. Do either 5 or 7 or both. Okay, I would say both. Then do number 9. That's the only one like that. Do any of the odds 11 through 17. Now, this new edition, here's one change to it. They are putting in red certain ones of these exercises, and I do not know. I'm going to have to read back and see why they do that. But definitely do 11, and then any of the others odds 13 through 17. Okay? Then do any of the odds, do 21 for sure, any of the odds 19 through 29. And then do either 31 or 33 or both. Those are piecewise defined functions, or one of them is. Okay? Take a look at 32. That answer is not in the back of the book, but if you have any problem with 32, bring it up to me next time. Okay? Then do 37 for sure, but any of the other odds, 35 to 41. Do 43 for sure, and then if you want to, do 45. And we'll stop there and pick up the rest of those next. Okay, all right. Here's what I mean if you want to, okay? If you breeze through the one that's suggested or indicated, then go to a harder one. And if you get them all done, say, hey, okay, I can do all those. Let's go to the next group. But do some of every group. Do some of the easier ones, some of the harder ones. If you get them all, you don't have to do them all. Yes? The thing is, the homework is for you to practice, because soon we're going to have a quiz. Then we're going to have a test. The homework exercises are going to be very similar to what you see on quizzes and tests. I would say, I don't know what the red means, but I'd say definitely do the red and then do any of the other odds. Now, why do I say odds? Okay, the answer's in the back, as in most textbooks. But if you look at the top of the thing on 1.4, look at what it says. See capchat.com for tutorial help and worked out solutions for the odd number exercises. So how I would approach these, do them on your own. Check in the back of the book. If you got the right answer, good, go on to the next. If you did get the right answer, see if you can figure out why not. If you can't figure out why not, go to caltrack.com and they'll give you the worked out solution If you still can't figure out why they did that step, bring it to class and ask. Good deal.
See if we could do odds from.
Okay. Oh, you don't have a book. Okay. Do number 7 and 5 if you want to. I would do them both. Do number 9.
7,
Do 11, and then any of the other odds, 13 to 17 that you want to. Do 21, any of the other odds, 19 to 29. Do either 31 or 33, or both if you choose. Do 37, any of the other odds, 35 to 41. Do 43, and then do 45 if you choose. Yeah.
This is new, and then I see this one. What is this?
Okay. Yeah, if this is plus, then these two signs have to be the same. They have to be the same as that. If that was a minus, that means these two signs have to be different. One plus or one minus. Then you have more trial and error. And just keep trying. If you don't get the right answer, try another when you go back and forth.
This is minus, and this is minus 5. This is the plus. We have to just put it in.
Yeah, try different ones, but you know that these two signs have to be different if that's a negative. Yeah.
So
And
this
you,
sign is that's determined by this one.
yeah, these signs here are determined first. If this is plus, they have to be the same. What sign is it? Look here, and they have to be minus. If that was a plus, then they both have to be pluses. Now, if this was a minus, and this is either plus or minus, these have to be different. And then you have to, when you pull it, you have to get the same sign as this.
Do I have an example like that in one of the?
No, that would be stuff in 1-1 to 1-3. The earlier stuff.
Would you go back with this class?
What's that?
Would you go back with this?
Okay,
class?
yeah.
Give
Well,
us
find some others that give you problems with homework, and I'll work any of those.
Yes,
Yeah.
thank you.
Okay, good deal. All right. Paper topic. Phone numbers. Email. Fantastic. Okay.
I wanted to ask you to make sure that I got everything.
Okay.
All the notes.
Oh, okay. Yeah.
And where in the textbook is this found?
It's on page 44 and 45. Okay.
I don't know what topic yet, and I just leave blank and I work on that later.
Yeah. You can ask me for this anytime and pick a topic. Yeah.
What would be the good place to find topics that just?
I'd say look through the book and see anything that interests you. Yeah. It could be people, phenomenon theory, whatever.
Oh, yeah.
What's that? Oh, yeah. No, if you don't want it, I'll take it. Okay. All right.
I just wanted to make sure I got everything.
Okay. Do 7. You can do 5 if you choose.
5 or 7 or both.
Yeah, but since 7's red, I definitely do 7. Okay. Do 9. Do 11, and then any of the others, 13 to 17.
Okay.
Do 21, any of the others, odds, 19 to 29.
Okay.
Do either 31 or 33, or both if you choose. Do 37, and any of the other odds, 39 to 41 if you choose. Do 43, and then 45 if you want to.
And that's
Yeah.
43 or 44.
Yeah, 43 and then 45 if you want to do another one.
Okay.
Just because you enjoyed it so much. It's not that funny. Okay, I'm just kidding. All right, good deal.
Is this okay? My topic.
Hey, yes,
Good?
it is fantastic.
Okay.
Yeah. I think of physics in that, but you can't do physics without trig, so yeah, really good topic.
You all have a good class.
What's that?
You all have a good class.
All right, thank you.
I mean, well, you already did, but.
All right.